At one extreme of thinking about the world, we have determinism. Determinism has no randomness at play at all. This is like your standard math problems. You throw in a set of inputs and you get one and only one output. No randomness involved, no randomness wanted or needed. At the other extreme, we have what we call stochastic processes. Now, stochastic processes are mathematical processes that are determined almost entirely by randomness. A great example of this is the random walk model, and it's playfully modeled after a drunk man who leaves the bar and walks home. And because he's so drunk, each step is sort of lurching him in a different direction. As you can imagine, it's going to take him a lot longer to find his way home than it would if he was sober and just deterministically walked from the bar to his house. So these are the two extremes. But when we're modeling out reality, a lot of times we need to blend these two extremes. And a fun example is how a photon of light interacts between where it's born at the center, at the core of the sun, and when it hits your skin 93 miles away on planet Earth. From the time that that photon of light gets from the surface of the sun to hitting your skin, and that's why you need the sunblock, it takes about 8 minutes to cover that 93 million miles. That's pretty deterministically driven. Just its direction is set. It travels at a blistering 186,000 miles a second. But an interesting question is, well, how long does it take for that photon of light to get from the center of the sun, where it was born, to the outside of the sun? On average, it takes that poor photon of light about 100,000 years. And if you're an unlucky photon, it could take you a couple million years to get from the center of the sun to the outside. Well, why? Why does it take so long? And the answer is that that path is largely driven along the basic lines of a random walk. It's so dense at the center of the sun that the photon that has the 430,000 mile journey to get from the inside to the outside, it ends up bumping into a big, mean atom about every inch and a half along the way of its journey. Imagine if you had to do a 430,000 mile journey and you got pushed off course every inch and a half. So what's the takeaway? What I was really trying to convey to you is that when we're trying to think about the real world and we're modeling, we don't have to accept this either or kind of decision making. It's either deterministic or it's stochastic. A lot of phenomenon have a layer of both. When the photon of light leaves the sun's surface, it's pretty much all deterministically driven, but the journey from the inside of the sun to the outside of the sun, that's all stochastic.